This presentation, North American Small Wind Certification, was presented on September 26, 2012 at the Bioenergy Web Seminar Series hosted by the University of Nebraska-Lincoln Extension and e-Extension at extension.org.
Welcome everyone to the Bioenergy Friday Web Seminar for September. My name is Sean Hay. I work for the University of Nebraska-Lincoln Extension, and we host these web seminars once a month on different bioenergy topics. And this year we've had kind of a variety of bioenergy topics. I'm excited about today's topic. We're getting back to small wind turbines, and we've done some web seminars on that years ago, and I'm happy to get back to it. I think it's an interesting topic and one that has interest to the public. I hope you guys will ask lots of good questions, and we have a good speaker today. Our speaker today is Brent Somerville, the Technical Director of the Small Wind Certification Council. He's going to give us an overview of what is the Certification Council and what it does and how it can impact consumers of small wind turbines. And I think that's been very interesting to follow through the last 4 or 5 or 10 years, all of the different companies that have tried to get into small wind turbines, some of them producing some poor products and some very good products. So I think that's going to be interesting to hear about. And with that, I'm going to turn it over to Brent. Welcome, Brent.
Thank you very much. Good morning. Thanks for the introduction and the opportunity to speak today on this topic. And as the title says, it's basically an overview of small wind certification in North America. This is what we're charged with handling, and I'm the technical director, so I'm sort of in charge of the nuts and bolts, making sure everything works with our certification program. Our executive director, you may know, is Larry Sherwood. As many of you know, small wind inspires a lot of interest. This is a quote from an article in Mother Earth News, someone who has a small wind turbine on their farm, and she states that the aesthetics of wind turbines are irresistible, and we steal a glance at ours almost every time we walk between the house, garden, and workshop. So they're very visible as far as technology and renewable energy, and a successful installation like this one at a farm in New York will tend to cluster other installations. So if you are interested in a small wind turbine, maybe you start with an internet search. And for example, if you go to allsmallturbines.com, you'll find there's 674 small wind turbines from 234 manufacturers listed there. So of course that's rather daunting. And so we'll start, with the premise of why we have certification in the first place with a couple of important questions. One is, how can the consumer make apples-to-apples comparisons between turbines? Now, I used to work at Appalachian State University in essentially a hotline, and we were tasked with helping people through this decision. We would use the Home Power Magazine Buyer's Guide and provide some rather conservative suggestions on turbines. But with certification, what's developing is a list of turbines that have been independently reviewed, and this is useful for consumers, as we'll see. Also, the incentive programs are very important to the small wind market. They provide financial incentives in areas which enables the market to grow and really reduces the cost of this investment for the consumer. They want to make sure that they're using this public funding for this incentive program on turbines that are high quality, they perform as expected, and they want to try their best to avoid unsuccessful projects. So why certification? There's an old article from 2004 from Mick Grillo called Keep It Spinning, and I always remember this. He drove through Wisconsin. He noticed this turbine that had malfunctioned, and the owner was a retired gentleman who left town and left it there unrepaired all winter long. And Mick quotes, wind turbine owners inadvertently become advertisers for renewable energy, whether they wish to or not. And a wind turbine that is spinning, whether it is generating electricity or not, is seen as doing something useful. as part of the solution. And one that is sitting idle calls into question the usefulness of the technology and even who made the decision to allow the wind turbine to be installed in the first place. So you see what I'm getting at. With this solar installation, can you tell if it's functioning properly? You really can't, although it probably is. But with a wind turbine that you've installed, if anything happens, even the most casual observer will notice that it's not spinning or it's broken. What's wrong with it? And then the bad news travels fast. So in the same way, the good news travels fast too. So we try to avoid this black eye on the industry. Now, certification doesn't say that nothing bad will ever happen, but it's a good way to assess the technology and try to avoid bad projects. And another example is just inaccurate power ratings. One of the deliverables from certification is a power curve that is the most accurate as possible, which leads to the most accurate energy estimates that are possible. Now, in California, they had an occurrence of a rebate where the payout was way more than the actual cost of this very small turbine because the inaccurate power ratings, which is what the California rebate is based on, $3 a watt. So that completely shut down, that loophole brought in over $30 million in rebate requests, shut down that program, and that program is continuing to struggle and rebuild itself in California. So bad things can happen when uncertified products are out there. So prior to 2010, certification was available. Essentially international standards out there for small wind turbines to be certified too, but it was just seen as time-consuming and expensive. There was a lack of testing in the U.S. It was essentially limited to the national lab in Colorado. There was also a lack of a certification agent in the U.S. The big business like UL and others had made it a business decision not to offer this product. And there was no market pressure requiring certification. So essentially it just wasn't happening. And you had a market of wild performance claims and a wide variety of quality of technology. So, in the background, all these problems were known in the industry. And I would say around 2006, two things began to develop. One was the new American Wind Energy Association, AWEA Small Wind Turbine Performance and Safety Standard. Now, this relied heavily and utilized those existing IEC international standards, but it tried to make modifications and optimize the process. Another a group that brought together a wide variety of stakeholders and input led to the creation of the Small Wind Certification Council. And as an industry, let's build a certification body just to certify smaller wind turbines to this new AWEA standard. So in 2010, just days after the release of the AWEA standard, the SWCC opened the doors and began accepting applications for certification to this AWEA standard. And really off we went. This also is leading to more organizations offering field testing, which is an integral part of certification. I will say, if I can go back to this slide, that this SWCC startup funding came from many of those states, such as New York and Canada, and mainly the Department of Energy. So we did receive some startup funding that will slowly go away and be replaced with fees for our service. So what is this AWEA standard? As I said, it incorporates with modifications those existing IEC International Electrotechnical Commission standards. So, around the world there are these standards writing bodies for IEC that bring experts in from all over the world, from throughout the industry, and write the standard on how to design and evaluate small wind technology. The AWEA standard brought together a group and said, how can we use these standards to provide an North American certification program? And essentially the goal is to ensure the quality of the wind turbine is assessed while imposing only reasonable costs and difficulties to the manufacturer. The scope of this standard is to newly manufactured wind turbines, and they can be really almost any architecture. You see pots, vots, and dots. That's horizontal axis wind turbines, vertical axis wind turbines, and diffuser augmented wind turbines, up to a swept area of 200 square meters, which is roughly 40 or 50 kilowatts. So here are some of the parties involved in this process. The manufacturer designs a wind turbine, and they provide this wind turbine to the market. They use an engineer to actually do some in-depth mechanical engineering calculations, which show that it's designed to last 20 years for extreme loading, fatigue loading, and everything that it's going to see in the real-world conditions. We review that structural analysis as part of certification. Now, they use a testing organization to install the wind turbine in the field and do several tests: power, performance, acoustics, safety and function, and duration testing is performed by this organization. And we're all reading the same rule book, the AWEA standard, which incorporates those IEC standards. Now, the SWCC is the certification body. You can almost think of us as the referees in the football game, where, you know, both teams know how to play the game, they know the rules, but someone has to be there independently, impartially, that knows the rules and makes judgment calls. And as we're seeing, there are always judgment calls. Now, we're missing a graphic here, which is A2LA. A2LA is the organization that accredits us as a certification body. So this certification that we're speaking of today is part of an overall scheme in North America. Here's the wind turbine, and there's really four things going on with this installation. The SWCC certifies the wind turbine system in terms of mechanical strength, durability, its function, and performance to this AWEA standard that we're speaking of. Now, we also have electrical safety listing going on with this, just like everything else in your house, the stapler, the toaster. It's all been tested for electrical safety, and these are issues mainly related to shock and fire, but the nationally recognized testing labs, such as UL, will provide electrical safety listing for this system, and that is to this new UL 6142 standard that's coming out soon. The installer installs and wires the entire system to this new article in the National Electrical Code, NEC Article 694, specifically for small wind turbines. And finally, the tower and the foundation are designed and certified by a professional engineer. They're using TIA 222G. That's a telecommunications standard for towers and cell phone towers that also provides design guidance for a small wind turbine tower. Now, it's similar to what they work on in communications, but now it's a live load on top, so it has some additional fatigue and other requirements. Okay, so I spoke about an increase in testing activity, and we keep an essentially yellow pages of testing organizations that provide this service. And we currently list about 27 organizations worldwide that offer field testing. 4 of those are new regional test centers that are set up and managed by our national lab, NREL. And we are open to testing from almost anywhere. So we don't do the testing ourselves. We are open to the testing coming from an accredited testing organization, such as our national lab, non-accredited testing organizations where we are required to visit them and witness the testing as it's going on, or even manufacturer testing, which involves further scrutiny to ensure impartiality by SWCC. Here's a map showing the active testing going on right now for the SWCC. So, as I said, there were many organizations interested or offering this service, but it's as the couple of years have gone by, we keep going back to the same few places to do this testing, and you'll see coded in green, this green hat is the National Lab in Colorado, TUV-NEL over here in Scotland, Myers Hill, and Intertech in New York. Those three are an accredited testing organizations. So those reports are generated, can write to us without any on-site visit from the SWCC. We also work with three non-accredited organizations. Here's one in the Panhandle of Texas, the Alternative Energy Institute at West Texas A&M in Canyon, Texas, as well as Windward Engineering out here in Spanish Fork, Utah, near Salt Lake City. And third, way out on the tip of Prince Edward Island is the Wind Energy Institute of Canada, or WECAN. Now, I've tagged those three with a red star, and we've just announced that we're calling these three organizations that I've already been to at least once or twice as preferred testing organizations. So what that means is you're an applicant and you want certification, you're going to have to decide with us where to do the testing. If you choose one of these preferred testing organizations, then that is essentially a path that we've been down. We know that they do good work. If we have to trailblaze a new testing organization, that's going to cost more and probably more issues to resolve, more time. So we're encouraging people to use testing organizations that we know just to help streamline the whole process. Now, in the UK, over here in the UK, they have a very strong feed-in tariff. Now, that is leading to a very strong market for distributed wind. And so 2011, for instance, was a pretty poor year in the U.S. for sales, but the manufacturers were still able to export to the U.K. because of its strong market. Therefore, many manufacturers of small wind turbines are seeking dual certification, both in the UK and in North America. So what we've done to facilitate that is sign reciprocity agreements with the certification bodies in the UK. So the manufacturer does one test, and we share information with their certification body in the UK, and essentially they're able to satisfy both requirements, or reduce cost and time frame, instead of essentially doing the same work twice. So this cooperation is leading to a harmonization of efforts globally. So as an SWCC update, after we opened our doors, we received many applications or notices of intent to apply for our certification. Right now we have 31 turbines under contract. Out of those, 18 have made it to the step of under test. They're now collecting data. We have 6 that are conditionally certified. That means they're certified in the UK, and now they're just working on the gap and the requirements to meet the AWEA standard, which there are several should go from conditionally certified to fully certified very soon. We have issued one temporary limited power performance certification. So for the Endurance S343, as they're moving through the process, we've certified their power performance, and all the remaining tests and certification work remains pending. But along the way, they can publish their power performance ratings as the process moves along. We've done that for Endurance, and we have certified 2 turbines fully to the AWEA standard at this point. And those turbines are the Berge XL10 and the Southwest Wind Power Skystream 3.7. Now, these are pretty well known, and they've made it through the process of testing, structural analysis, and have received our independent review. And we list them on our website with these ratings along with other reports. So we list the rated annual energy. This means an estimation of how many kilowatt hours would be produced at a site with a Rayleigh typical distribution of wind with an average wind speed of 5 meters per second. And of course, your results will vary, but this is a way to compare energy output between turbines at this given assumption. Also, we rate we list the AWEA rated sound level. This is what it sounds like as an observer 60 meters away from the rotor at a certain wind speed, about 10 meters per second. So this is another way to compare turbines. Is it louder than the other or quieter than the others? And the rated power is taken at from the power curve at 11 meters per second. So nominally, we describe it. They describe it as a 10 kilowatt turbine, which it does reach. But at 11, at this common point, it's producing 8.9 kilowatts. The SkyStream 2.1 kilowatts. So on the website, we do produce this consumer label. Now, this is meant to be essentially one of those hang tags like you see on a washer and dryer at a store. So it's a way for consumers to boil down the results of all this certification to these 3 single number ratings. For more savvy customers, we also provide a summary report which condenses all the test report results into a basic summary report with all the power curves and energy curves and acoustics data in there. And we always provide the certificate online, so it's a way to go and check the validity of the certification of the turbine at any time. And in the very beginning of the presentation, we noted that prior to 2010, there was just no market pressure for certification. But now that certification is on its way and turbines are becoming certified, several incentive programs are requiring certification for eligibility for their program, including Oregon, Wisconsin, New York, Massachusetts, California, and many others. Vermont just added it to their requirements. It's also being used for being listed on the Interstate Turbine Advisory Council, ITAC, unified list of wind turbines. Now, this includes small wind turbines, medium wind turbines, and they use certification as a pathway onto their list. And I did discuss this new UL 6142 electrical safety standard. Essentially, the AWEA standard is a prerequisite for that. They want to see that the turbine has sound mechanical testing and certification to bolster the UL listing of the entire system for electrical safety in UL 6142. So finally, I didn't want to speak too much about incentives because essentially the incentives for small wind turbines, it varies. Are you residential? Are you a commercial entity? Are you agricultural? Are you in Vermont? Or what state are you in? So we all are benefiting from the federal 30% renewable energy tax credit, but this is a good starting point, I think, for working on what incentives are available to you. We've got this nice widget here for Desire, the database of state incentives for renewable energy and energy efficiency. You can just put in where you live and who you are and view a summary of the incentives for RE or TE. And on this same launching point, you can go to this new distributed wind policy comparison tool, which allows you to do some financial comparisons and modeling of cash flow for small wind turbines. And you'll see some other good links on here too. So that's why I'm posting this. Recommended jump point is windpolicytool.org. Okay, well that concludes this presentation. I look forward to any questions that might come in.